Today I'm recording a short video on Dalton's law of partial pressures, and we know that a partial pressure is simply a pressure of a component gas in an overall mixture of gases. And Dalton's law of partial pressures states that the total pressure of a gas mixture is the sum of the partial pressures of the component gases. Okay, and that can be represented by total pressure equals pressure 1 plus pressure 2 plus pressure 3 plus however many other component gases there are. And typically in the lab, we are actually going to use water displacement to figure out what the partial pressure of a gas is. We use the atmospheric pressure and the pressure of water vapor at a given temperature to figure out what the pressure of the component gas is. And so to figure out, you will be given the atmospheric pressure typically, and you need to know what the temperature is so that you can determine what the water vapor pressure is. And you will typically be given a temperature in degrees Celsius. There is a table in the back of your book on page 859, and it is table A8. And you can see that temperatures in degrees Celsius of water are listed, and also you see pressures that are listed in millimeters of mercury or kilopascals. In this class, we'll actually stick with the millimeters of mercury. And don't forget that millimeters of mercury are the same numerically as torrs, which is another unit of pressure. Okay, so we know we have this table, so we're actually going to take a look at problem number 5. Let it focus. We're going to take a look at problem number 5, which is on page 367. And number 5 says, a sample of nitrogen gas is collected over water at a temperature of 23 degrees Celsius. What is the pressure of the nitrogen gas if atmospheric pressure is 785 millimeters of mercury? So we're trying to determine the partial pressure of that nitrogen gas at 23 degrees Celsius when the overall atmospheric pressure is 785 millimeters of mercury. So how we'll set that up, we know that our total pressure is 785 millimeters of mercury, and we're going to set that equal to the addition of the two partial pressures. Well, we're looking for the partial pressure of the nitrogen, and we're going to add that to the partial pressure of water. But we don't have the partial pressure of water in this particular problem. We're just given the temperature, which is 23 degrees Celsius. So we're going to take that 23 degrees Celsius and turn to page 859 and find out what the partial pressure or the pressure of water vapor is at 23 degrees Celsius. And you can see on the right-hand side that it is 21.1 millimeters of mercury at 23 degrees Celsius. So I'm going to plug that number in right here, 21.1 millimeters of mercury. And to solve for the pressure of nitrogen, I'm simply going to subtract the 21.1 from 785, and that'll give me my partial pressure of nitrogen in millimeters of mercury. If I subtract from this side, that number no longer exists on the right, and I'm going to subtract 21.1 millimeters of mercury from 785, and that will leave me with 763.9 millimeters of mercury, which is the partial pressure of the nitrogen. However, we need to pay close attention to significant figures, and I can see that by my two measurements, both of my numbers have 3 significant figures, so my final answer should as well. The 9 right here is going to make the 3 round up, so my final answer should actually be 764 millimeters of mercury is the partial pressure of nitrogen. And that's your final answer for problem number 5 on page 367.